Welcome back to our system design series. Today we are diving into another important caching strategy called write back cache, also known as write behind cache as well. This approach is designed to optimize write performance by asynchronously updating the database, making it a great option for certain use cases where write speed is critical. So let's try to see an example to understand how a write back cache works. Let's say that we have an application and the application will send requests. Let's take this from here. The application, and we have the caching. Let's say the cache, and we have database. So as you can see that the cache is set as well in line with the database. So in this caching strategy, when an application needs to write data, it writes the data to the cache first, and the cache then acknowledges the write to the application immediately, indicating that the write operation is complete. After that, the cache takes responsibility for writing the data back to the database at a later time, asynchronously. This means that from the application's perspective, the right operation is much faster because it doesn't have to wait for data to be saved in the meantime. So again, let's understand how this will work. When the application tries to write data to the cache, okay, the cache immediately save it and acknowledge the right to the application. Basically, it acknowledge it back. Okay, allowing the application to continue processing without any delays. Okay, later it will the cache will write the data to back to the database, but later, not immediately. Asynchronously. This is happening asynchronously. This write can happen in the background without blocking the application's operation. This caching strategy is ideal for scenarios where write performance is crucial and the system can tolerate a slight delay in updating the main database. Since the write back acknowledges the write immediately, it improves significantly. It provides significantly faster response times compared to write through cache. So, what is the benefits of this strategy? The first thing we said before is the improved of write performance. The primary benefit of let me use text instead of just to type it like this way because I guess it doesn't make sense. So the first thing will be the improve write performance. Oh, let me make it smaller. Yeah. This is the first thing that we will get from, we will benefit from using a back cache strategy or write back cache strategy. The primary benefit of the write back cache is the speed of write operations by immediately acknowledging writes. The cache significantly reduce latency, making it excellent choice for applications that require very fast write capabilities. The second thing will be reduce the load on the database. So by batching writes to the database, write back cache can also reduce the total number of write operations, decreasing the load on the primary database and potentially lowering infrastructure costs. And number three, which is resilient to short-term failures. This is an important thing to talk about. Like write back cache can tolerate short-term database downtime since the writes are first stored in the cache. This allows the cache to keep working while the database is temporarily unavailable, for example. But there are some drawbacks to come with the write back cache. The first thing is the risk of data loss. One of the key drawbacks of write back cache is the risk of data loss. If the cache fails before the data has been written to the database, the data may be permanently lost. This makes write back less suitable for systems where data integrity is absolutely critical. The second thing will be complexity, because like the asynchronous nature of write back cache adds complexity to the system. Mechanisms must be in place to handle potential failures during the write back pressures and to ensure that the data eventually reaches the database. So let's try to answer the questions. When, let's make it bold, when should we use it, this strategy? So I would say if you have a write heavy application, heavy up. If you have a write heavy applications where write speed is more critical than immediate consistency, such as analytic system loggings or sensor data collection. Number two, a system that can tolerate eventual consistency if there is no problem with eventual consistency. And number three, scenarios where you want to minimize the load on the database by patching writes, reducing overall write frequency. So yeah, that's it for this video. And if you like this video, make sure to subscribe and hit the notification bell so you will never miss any video. And see you in future videos.